So today on the bench we're gonna look at the CMU 200 again, because why not? So I built a small bandpass filter here, and I plugged that into the two ports of the unit. So okay, just move that over. So I plugged it into the RF in and the RF out, so nothing special. So that we can actually sweep through here and actually see the performance of our bandpass filter, which, if we actually look at the spectrum, looks more like a band stop filter, which is weird. So I'm apparently not good at building RF filters, but that's a different story. The main reason why I want to make this video is actually not to how to design filters, because this spectrum analyzer is telling me that I'm really horrid at building filters, but I rather want to say how you can actually get these curves, because this unit does not have a tracking generator inside of it, or anything like that. It doesn't have a noise source within it as far as I'm concerned either, so getting a line like this isn't too hard, but it's not too trivial either. So how I made this line was by using the RF generator and then just sweeping across with the frequency manually. So what we can do is we can go up here and just change this so that we can take everything away from the screen. Then we can go over here. So what I did was I manually just rotated this, so practically just going through and sweeping by hand. And yes, if you do it too fast, it's just gonna look like this, because it doesn't have enough time to actually sweep. Though one could actually go here and just outline the signal fairly quickly. So it's not a horrid way of actually doing it, because you can get kind of what you're looking for fairly quickly, even though an actual tracking generator would have been 1,000 times more preferred. But this unit does not have one. So yeah. So you can just go through like this and just slowly fill everything in. And I'm not gonna take you through all of this pain that I recently went through to get this signal. Because, okay, honestly, you don't need to fill it in this much to actually see the waveform. Like, all of these peaks are kind of telling us what we're looking at. It's a bit like using a comb generator and using that to get a lot of peaks to outline the performance of our filter. So it kind of works. So doing this method is a bit like using a comb generator, except we can actually go through and really more accurately sweep across everything here. Where did our line go? In here somewhere. But yeah, so we can just do this to slowly fill out our... Oh right, I touched the cable. Maybe that is the reason for why we aren't perfect here. Might be an air gap or something internally. No, it still looks like a band stop filter. So yeah, that wasn't really the reason. So yeah, one can go through in this fashion. It's not comfortable, user-friendly or anything like that. The reason for why this works is because we're putting our RF generator at a specific location within this, and then the spectrum analyzer is sweeping across, and then we can slowly fill in by just moving our tracking generator one step over every time. And to be capable of doing this, we are setting our display mode on the spectrum analyzer to maximum, because if we set it to minimum, for example, don't see anything, and if we set it to average, we don't see anything, and if we set it to current, we just see what we're feeding in at the moment. All of them rather useless. But maximum is actually telling us something. It's actually telling us quite a lot of stuff, actually. It's not perfect. I would really have liked if Rodenswartz would have actually put in a software-based tracking generator, because literally what it could have done is sweep the RF generator at the same pace that it's sweeping the spectrum analyzer, and that wouldn't have been hard, because the spectrum analyzer isn't, or rather any spectrum analyzer on the market, is not sweeping all that fast. Because if a spectrum analyzer is sweeping really fast, then it kind of gets counterintuitive to how it actually needs to work. Because what a spectrum analyzer is doing is that it looks at a specific frequency, and so partly when it sweeps across, it filters out a specific frequency, and then it lets hundreds, if not millions of cycles of that frequency pass through. And then you have an RF detector, which you're looking at these different types of, but practically you can look at the value from that RF detector. We have that over here. So currently we're looking at the RMS value from that detector, because it just converts the amplitude of the incoming frequency or the incoming signal into a voltage. We could also set that to peak, which gives us a totally different result. So with RMS we are down here, and with peak we're all the way up here, so it's a fair bit different. So I have it in RMS, you could have it in peak. It really matters depending on what you're doing, because they are different. So that's the big thing. They could have added a tracking generator with just a couple of lines of code, which is a bit weird why they didn't do that. Or rather, why they didn't do that is probably because this is a professional piece of instrument that isn't really even meant to be a spectrum analyzer, it just happens to have that functionality. Because this is actually meant to be a GSM base station, practically a mobile phone test set. So this is not really meant to be your bench, piece of bench equipment. This is meant to be in production and actually testing things, consumer products and stuff. So that they didn't add that type of functionality to actually add a tracking generator does not really surprise me. But it would have been a nice gesture. And if Rodenswartz ever does a software-based tracking generator option for this, which wouldn't be too hard to do because there's actually people doing that with an external PC connected to the GPIB port of this, really slow. So having one internally would have been a bit better. So you can do a tracking generator for this in software, and that would have been nice. And then it would technically also be capable of doing like offset tracking and everything like that, so it would actually be quite capable quite easily. So I'm a bit annoyed that they didn't add it. But yeah, we could actually go through here. Oh right, need to go into the right setting and fill this up slowly but surely, and just see how this filter is performing. And it's not a nice filter, but it kind of works. Or not really, but I wouldn't really use this filter, it looks weird. I'm a bit curious to why it's this word. Because it's just an RC filter, but it would still be nice if there were just a very simple tracking generator option. They could have had it here on the generated menu, just a button, like tracking generator, and it just does it. Would have been nice. And then you could have like offset tracking besides, but nope, they didn't settle for that. Like, I don't require more. Like, if it cost, let's say, 100 euros, I would pay it up front. It would be worth it. At least as far as I'm concerned, it would be worth 100 euros. Because it would add so much functionality to this unit. Because not having a tracking generator, like, it has all the tools necessary to have a software-based tracking generator instead of using an external one. And yes, you can use an external tracking generator if you know the sweep speed of the spectrum analyzer, and you know what more do you need to know? You need to know a fair few things actually. The span, the center frequency, the sweep speed, and the resolution bandwidth is kind of the things you need to know. And then you probably want some form of way of synchronizing your two units. I'm not all that much into software-based tracking generators. I'm no expert, but they could have added one, and that would have been nice. But now I probably rambled on too much about tracking generators in this video. Like, this is probably coming off how easy this is to do. Okay, what you could do is you could just go up here and with singular megahertz and look at your signal. Okay, let's actually go through and see if we can find something that's a bit more interesting. Where is this? There you are. Yeah, let's take a closer look at this. So we center our marker, then we lower our span, let's go down to 100 meg span. And where is our marker? Our marker is at 950 roughly. So 950, have it, and we can sweep across here and see that we practically have nothing here. And I thought this was going to be an interesting region. And yeah, the reason for why it looks this horrid is just because I'm sweeping across very fast. So let's clean it up. Yeah, there's nothing there. Don't need to get too many buttons in this unit. But yeah. So they could have done a software-based tracking generator, and it would have been a nice option for everyone thinking, surely there must be a software-based tracking generator option somewhere. Like, this unit has a lot of menus after all, but I haven't found one. I haven't found any documentation for it, I haven't found it in the manual, I have not found any software options for it, I haven't found anything. I found a few people on the internet talking about actually hooking in and building a hardware-based tracking generator for this unit, but not anyone actually doing a software-based one inside of the unit itself. Except people doing it externally through the GPIV port, but which you could do by sending a command to this to set itself on a certain frequency, set the generator to that same frequency, have this then feedback to the measurements from that frequency, and then step over one step and do the same thing repeatedly. So, and then show all the results on the PC. Because this is not going to do it for you. So yeah. So that is that's my take on it, but I'm probably going to end the video here because I'm rambling on far too long. How long have I been rambling? 14 minutes, yay. Well, if you made it to the end, then congratulations to stand my rambling. No, that wasn't anything interesting. Or are those two something interesting? Nope and nope. Yeah, it's just a flat line. Well, that's about how interesting that gets. If we zoom in on this then. It's not really a flat line, it's actually having a bend to it. Well, then we know that. And yeah, I could probably go in and take away a bit more of that noise. So yeah. But I'm gonna end it here, so 15 minutes, how nice.